So what is the Central Business District Tolling Program? In 2019, New York State enacted the MTA Reform and Traffic Mobility Act, which authorized the Triborough Bridge and Tunnel Authority, or TBTA, to design, develop, and implement a vehicular tolling program to reduce traffic congestion in the Manhattan Central Business District. As defined by the Act, vehicles entering or remaining in the Manhattan Central Business District on or below 60th Street, which is shown in the map in orange, would be tolled. The FDR Drive, West Side Highway, Battery Park Underpass, and any surface roadway portion of the Hugh L. Carey Tunnel connecting to West Street, in essence, the dark red line along the edges of the orange area on the map to the right, would be excluded from the toll. After covering the project-related capital and operating expenses, revenue collected would fund MTA's 2020 to 2024 capital program and successor capital programs. By law, 80% of the net revenues would be used for New York City Transit capital improvements, 10% would be used for Long Island Railroad, and 10% for improvements for Metro North Railroad. With respect to how the Manhattan CBD tolling program would work, locations for infrastructure would include detection points placed at entrances and exits to the Manhattan CBD. On the avenues, these detection points would generally be between 60th and 61st Streets, and an algorithm would be used so those who stay on excluded roadways are not tolled. In essence, as someone is coming down the roadway, the detection points would detect their vehicle and determine how long it should be before they're seen at the next location. Assuming they continue to be seen at each location within the allotted time, no toll would be charged. If, however, the vehicle is not seen and then not seen again, at some point the system will determine that they must have entered the Central Business District and a toll would be charged. On the right, you can see an example of what the infrastructure and the tolling system equipment would look like. It's predominantly poles, as you see on the right, and mast arms, as you see on the left. Importantly, the tolling system equipment will be clustered and housed in a single unit enclosures, as shown on the bottom. The enclosures are purposely designed to minimize the amount of equipment on the poles and to reflect light in a way that makes them less visible to someone walking or driving. With respect to how customers would pay, it would be very similar to what people experience today. They would be able to pay with EasyPass or tolls by mail, where an image is taken of the license plate and a bill is mailed to the registered owner of the vehicle. And we will also have the capability for future third-party providers. In essence, these are companies that may use different types of technology that can link into the technology that this system would have. The benefits of the program would include reduced vehicular traffic in and near the Manhattan Central Business District, improved travel times within the Manhattan Central Business District, including for buses and deliveries, and a new source of local recurring capital funding for subways, trains, and buses, as well as improved regional air quality. So why is an environmental assessment, or EA, needed for this project? Well, some roadways in the Manhattan Central Business District have received federal funds, so approval for tolling is needed from the Federal Highway Administration. Before a federal agency makes a decision, the National Environmental Policy Act, or NEPA, requires the federal agency to understand and disclose the environmental effects of the action, in this case, the tolling. An EA is performed to ensure federal agencies consider the environmental impacts of their actions in the decision-making process. For a proposed action that is not likely to have significant effects, or when the significance of the effect is unknown, the EA aids in determining the significance of the adverse effects. Since the project could have effects on environmental justice populations, Federal Highway Administration and the project sponsors incorporated enhanced public outreach and coordination with federal and state resource agencies. The project's purpose is to reduce traffic congestion in the Manhattan Central Business District in a manner that will generate revenue for future transportation improvements, pursuant to acceptance into Federal Highway Administration's Value Pricing Pilot Program, or VPPP. The need is to reduce vehicle congestion in the Manhattan Central Business District and create a new local recurring funding source for MTA's capital projects. The purpose and need are refined through 4 objectives: to reduce daily vehicle miles traveled, or VMT, within the Manhattan Central Business District by at least 5%, to reduce the number of vehicles entering the Manhattan Central Business District daily by at least 10%, to create a funding source for capital improvements and generate sufficient annual net revenue to fund $15 billion for capital projects for the MTA capital program, and to establish a tolling program consistent with the purposes underlying the New York State legislation entitled the MTA Reform and Traffic Mobility Act. You may be asking, why do we need to toll the Manhattan Central Business District? Well, traffic congestion has been a problem in the Manhattan Central Business District for many years, and one of the most challenging policy problems for generations. Many efforts have been made, and yet congestion in New York City consistently ranks among the worst in the United States. Indeed, congestion costs 102 hours of lost time, equating to almost $1,600 per year per driver in delay. Between 2010 and 2019, travel speeds fell 22% in Manhattan Central Business District, and local bus speeds have declined 28% since 2010. The average speed of select bus service, New York City's bus rapid transit service routes, in the Manhattan CBD is 19% slower than in the outer boroughs. With respect to MTA's subway, rail, and bus systems, they need to be repaired and modernized. Funding from the project would support the 2020 to 2024 capital program and the successor programs that prioritize investing to improve reliability, committing to environmental sustainability, building an accessible transit system for all New Yorkers, easing congestion and creating growth, and improving safety and customer service through technology. I'll now walk you through the findings of the environmental assessment. There were two project alternatives that are evaluated in the environmental assessment. The no action alternative, in which there is no program to toll vehicles in the Manhattan Central Business District, no comprehensive plan to reduce congestion, and no new annual recurring funding for MTA capital programs. And there is the central business tolling or action alternative, where we implement a tolling program consistent with the Mobility Act to toll the vehicles entering or remaining in the Manhattan Central Business District. We install tolling infrastructure and tolling system equipment and signage within and near the Manhattan Central Business District, and generate funds for MTA's capital investments in subways, buses, and commuter railroads. The environmental assessment explores each of the topics in this chart. The specific chapters that address the analysis for each area are identified here. As you can see, the analysis shows that most of the areas have beneficial effects or no adverse effects, but there are a few areas with potential adverse effects. The slides a bit later in the presentation will address each of the areas and identify any mitigation that is needed. This slide has a lot of information, and it is in the executive summary and in Chapter 2 of the environmental assessment for further review. I am going to spend a few moments reviewing and explaining it here so everyone can understand its importance. As I said a moment ago, there are two alternatives for this environmental assessment: the no action and the central business district tolling alternative. Within the central business district tolling alternative, there are a number of tolling scenarios that vary in several ways. Modeling these different scenarios helped us to understand the full range of effects of the central business district tolling alternative, since the decision on the actual tolling scenario has not yet been made. For those of you who participated in the early outreach, you may notice that we now have 7 tolling scenarios when we originally discussed 6. That is because we added a tolling scenario, which I'll get to shortly, as a result of concerns raised during the early public outreach. So let me walk you through. Along the top are the tolling scenarios. Tolling scenario A we refer to as the base plan. This is the plan that is characterized in the legislation. Tolling scenario B has that same base plan, but starts to add caps in the form of how many times a vehicle can be tolled and certain exemptions. Tolling scenario C adds what we call low crossing credits for vehicles using tunnels to access the central business district, with some caps and exemptions. Those crossing credits, when they are low, are roughly $6.50. When they are high, as you see in tolling scenarios D, E, and F, the credits are roughly $13, and this was used for modeling purposes. In D, E, and F, you see those high crossing credits. In D and E, they are applied to the tunnels that enter into the central business district. And in F, vehicles using all of the tolled facilities that enter Manhattan would be eligible for crossing credits. Moving down the left side, you see the distinction on the items that are varying. First, the potential crossing credits. Again, these are credits that would be applied toward the Central Business District toll for tolls paid at facilities prior to entering the Central Business District. As you move to the right, you can see the no's and yeses, which determine whether or not that potential crossing credit applies to the facilities that are identified. Moving to the next group are potential exemptions and discounts in the form of caps on the number of tolls per day. Importantly, by legislation and in the modeling and in the program, passenger vehicles would be charged only once per day, but other vehicles could be charged more than that. And as you read across to the right, you will see under each of the different tolling scenarios how these different types of vehicles were treated with respect to caps or exemptions. Finally, as you move to the bottom, we have the approximate toll rate for autos, small trucks, and large trucks that resulted from the modeling. The one tolling scenario I'd like to mention is tolling scenario G, all the way to the right. This tolling scenario has a base plan with the same tolls for all vehicle classes. We'll talk about that a little bit later in the presentation, but importantly, as you see on the bottom, the toll rate is set the same for every type of vehicle. So that was a lot of information, and so I'd like to leave you with some key takeaways. First and foremost, tolling the Manhattan Central Business District in all scenarios reduce traffic entering the Manhattan Central Business District and results in a net benefit in congestion reduction for the region. Discounts, crossing credits, and exemptions result in the need for higher toll rates. Higher toll rates lead to a greater degree of traffic reduction in the Manhattan Central Business District, but also lead to increased traffic diversions, including increases along the Cross Bronx Expressway and the Staten Island Expressway. Crossing credits lead to more parity in the total cost among different routes that are taken by vehicles entering the Manhattan Central Business District. But those same crossing credits change the balance of effects on traffic. They result in less effect reducing traffic from Queens and much less effect reducing traffic from New Jersey. They result in greater effects reducing traffic from north of 60th Street in Brooklyn. And they result in more traffic at the Queens Midtown Tunnel, the Hugh L. Carey Tunnel, and the Long Island Expressway. Before we move on, I thought it was helpful to give at least a sense of where are the commuters actually coming from into the Manhattan Central Business District. On the left, you can see the 28-county region. Again, this is all in the environmental assessment for further review. The colors on the map denote the proportion of total commuters to the Manhattan Central Business District from each county in the 28-county region. The map also shows how many commute by transit, car, or some other transportation mode to reach the Manhattan Central Business District. Not surprisingly, counties that are further away tend to have fewer commuters to the Manhattan Central Business District. For example, of all the commuters to the Manhattan Central Business District, fewer than 1% come from counties like New Haven and Dutchess. About 1 to 3% come from counties like Rockland, Morris, and Richmond, and roughly 4 to 5% come from Bergen, Hudson, and Westchester counties. Closer in, about 6 to 10% come from Nassau County and the Bronx, while the remainder of the New York City boroughs contribute 11 to 22% of the commuters to the Manhattan Central Business District. On the right, in the figure, you can see that of all the people commuting to work in the Manhattan Central Business District, the vast majority, 85%, commute by transit. Of the 11% who commute by car, approximately 8% of them are from counties in New York, roughly 3% in New Jersey, and less than 1% from Connecticut. Now we'll go through the effects of each of the topic areas. On the top right of each slide, you'll see that we've identified whether effects are beneficial, not adverse, or adverse. In this case, this is the regional effects of transportation. Broadly speaking, all tolling scenarios reduce the number of vehicle entries into the Manhattan Central Business District and reduce vehicle miles traveled in the Manhattan Central Business District. The table on the bottom left provides the degree to which the traffic is reduced. In this case, there's a reduction of vehicles entering the Manhattan CBD of nearly 20% to roughly 15%, depending upon which tolling scenario one is looking at. On the right-hand side, you see the increase or decrease in daily vehicle miles traveled for each of the areas throughout the 28 counties. And as you can see, broadly speaking, regionally, again, there's largely a benefit. In the Manhattan Central Business District, VMT decreases anywhere from a little over 9% to about 7%. Throughout New York City, the reduction is roughly 1.5% to about 0.7%, and so on down the group. With respect to highways, we have beneficial effects, and we do have some adverse effects in a few locations where mitigation will be required. Some locations experience a decrease in congestion, which is a beneficial effect. There were 3 highway segments, though, that would experience adverse effects in the form of increased delays at certain times. As you can see here, it's the westbound Long Island Expressway near the Queens Midtown Tunnel in the midday. Approaches to the westbound George Washington Bridge on I-95 also in the midday. And in the evening, the southbound and northbound FDR Drive between East 10th Street and Brooklyn Bridge. For mitigation, the project sponsors implement a monitoring plan prior to the project beginning that identifies thresholds for adverse effects. If the thresholds are reached as a result of the project sponsors will institute transportation demand management measures, such as ramp metering, motorist information, or signage, at identified highway locations with adverse effects. In addition, post-implementation, the project sponsors will monitor effects, and if needed, Triborough Bridge and Tunnel Authority, TBTA, will modify the toll rates, crossing credits, exemptions, and/or discounts to reduce those adverse effects. Note the call out in the upper right, and recall what I mentioned regarding tolling scenario G earlier. During our early outreach and conversations with environmental justice communities, we shared information regarding changes in traffic patterns. Here on the left, you can see one of the maps that was used for analysis related to traffic and air quality effects. These are areas with environmental justice communities. Under this tolling scenario, some of these communities would experience reduced vehicle miles traveled. Others would see some increases as traffic diverts to avoid the toll. As noted earlier, as the toll goes up, these diversions increase. Participants raised concerns about the increased traffic along the Cross Bronx Expressway and asked what that meant in terms of truck traffic, as trucks are associated with particulate matter and associated health effects. The team reviewed the initial 6 scenarios at a specific location, McCombs Road, and found the daily increases in truck traffic in the table to the right. During this same outreach period, the trucking associations also raised their concerns that people can move to transit to avoid the toll, but trucks cannot do this. Further, though tolled bridges, roadways, and tunnels typically charge higher tolls for trucks given the wear and tear on the roadway, the purpose of this project is to reduce congestion. The project team looked closer at why trucks were diverting in the modeling. We found that the extent of the diversions was linked to the truck toll and price differential in the initial 6 tolling scenarios where trucks are tolled at a higher price. To test this, we created tolling scenario G, which prices all vehicle types the same. The result, as you can see, reduced the diversions along with the relative incremental number of trucks on the Cross Bronx Expressway. Given the concerns raised, the project team decided to include this tolling scenario formally in the environmental assessment. With respect to local intersections, again, there are beneficial effects and adverse effects where mitigation is required. Specifically, most intersections would experience decreases in delay. Tolling scenarios D, E, and F, the high credit scenarios, had 4 out of 102 intersections that experienced adverse effects in the modeling in the form of increased delay at certain times, and you can see them here on the right. Project sponsors will monitor those intersections where adverse effects are identified and implement appropriate signal timing adjustments to mitigate the effect per New York City Department of Transportation's normal practice. In terms of transit, we found beneficial effects and some adverse effects where mitigation is required. With respect to beneficial effects, reduced roadway congestion would result in reliable, faster bus trips. There is an increase in transit ridership of 1 to 2% system-wide for travel to and from the Manhattan Central Business District, but no adverse effects from increased ridership on any lines or transit stations. We do see that some scenarios increased ridership could adversely affect passenger flows at specific stairs or escalators, what we refer to as station elements. With respect to mitigation, in tolling scenarios E and F, TBTA will coordinate with New Jersey Transit and the Port Authority of New York and New Jersey to implement a monitoring plan with specific thresholds for pedestrian volumes on a specific station stair in Hoboken Terminal. If the thresholds are reached, TBTA will coordinate with these agencies to implement signage and wayfinding. In all the tolling scenarios, TBTA will coordinate with MTA's New York City Transit to implement monitoring plans with specific thresholds at the locations bulleted here. At 42nd Street and Times Square, there's a specific stair affected, and if the threshold is reached, the center handrail will be removed and the riser will be adjusted. At Union Square Subway Station and Flushing and Main Street Station, there are 2 escalators, one in each, that could be affected. If the thresholds are reached, we would increase escalator speeds. And at Court Square, there's a stair affected. If the threshold is reached, we would construct a new stair to increase capacity. With respect to pedestrians and bicycles, the EA found that increases in passengers at transit hubs would have no adverse effects. There would be some increases in bicycle trips overall and near the transit hubs, but again, no adverse effects. Outside the Manhattan Central Business District, increased transit usage at individual stations would not adversely affect pedestrian conditions on nearby sidewalks, crosswalks, or corners. But within the Manhattan Central Business District, there are 2 crosswalks and 1 sidewalk that would be adversely affected. You can see here on the right with the red lines that they occur on 8th Avenue, near West 32nd Street and 7th Avenue, and on West 34th Street and Avenue of the Americas. For mitigation, the project sponsors will implement a monitoring plan with thresholds for action. If the threshold is reached, pedestrian space would be increased and obstructions will be removed or relocated. With respect to parking and to social conditions, specifically population characteristics and neighborhood character, we found either beneficial effects or no adverse effects. With respect to social conditions, improvement in travel time and safety, reduced vehicle operating costs, and reduced emissions would occur from the project. There would be no adverse effects on neighborhood character or access, travel to employment within the Manhattan Central Business District or reverse commuting, traffic patterns on local streets or community facilities and services. With respect to parking, the study found a reduction in parking demand within the Manhattan Central Business District, an increased parking demand at subway and commuter rail stations and park and ride facilities outside of the Manhattan Central Business District. But the increase at any individual location would not be large enough to result in an adverse effect from the project. Economic conditions found increased productivity as well as safety improvements. There were no adverse effects to any particular industry or occupational category in the Manhattan Central Business District. Depending on the tolling scenario, the toll could reduce taxi and for hire vehicle revenues in the Manhattan Central Business District. While the industry would remain economically viable overall, individual drivers could be adversely affected, and this is dealt with a little bit later in the presentation. In terms of energy and noise, again, there are beneficial effects and no adverse effects. With respect to energy, the region would benefit from reductions in regional energy consumption as a result of reductions in the vehicle miles traveled. In terms of noise, 102 intersections were assessed and all the crossings into the Manhattan Central Business District. The study found imperceptible increases or decreases in noise levels resulting from changes in traffic volumes. With respect to air quality, the environmental assessment found that regionally, air pollutants would be reduced, including precursors to greenhouse gases. There would be no local exceedances of air quality standards. Recognizing that air quality is of great concern to many constituents, we have several enhancements, though there were no local exceedances of those standards. New York City Department of Transportation will coordinate to expand the New York City Community Air Survey network of air quality monitors. This will be supplemented by a small number of real-time monitors for particulate matter. Also, based on feedback during outreach for the project, MTA will prioritize Kingsbridge and Gun Hill bus depots, both located in and serving primarily environmental justice communities in Upper Manhattan and the Bronx, when electric buses are received in MTA's next major procurement of battery electric buses. In terms of environmental justice, the study did find adverse effects where mitigation is required. The map to the right shows the communities that are environmental justice communities throughout the region. They are widespread. And as shown earlier, in some cases, certain EJ communities will benefit directly from this project. However, the project would have the potential for disproportionately high and adverse effects on low-income drivers who do not have an alternative transportation mode for reaching the Manhattan Central Business District, and on taxi and for hire vehicle drivers in New York City, many of whom identify as part of an environmental justice population. This adverse effect occurs specifically in tolling scenarios that toll their vehicles more than once per day. We have a number of mitigation for low-income drivers, which you can see here on the left. There will be a tax credit for Central Business District tolls paid by residents of the Manhattan Central Business District, whose New York adjusted gross income for the taxable year is less than $60,000. CBTA will coordinate with New York State Department of Taxation and Finance to ensure availability of documentation needed for drivers eligible for the credit. CBTA will also post information related to the tax credit on the project website, with links to the New York State Department of Taxation and Finance website to guide eligible drivers to information on claiming the credit. CBTA will also eliminate the $10 refundable deposit required for EasyPass customers with no credit card linked to their account. It will increase promotion of existing EasyPass payment and plan options, and will work with MTA to increase outreach and education on eligibility for existing discounted transit fare products and programs. The project sponsors will establish an environmental justice community group that will meet on a biannual basis, with the first meeting 6 months after project implementation, to share updated data and analysis and hear about potential concerns. For effects on taxi and FHV drivers, the project sponsors will work with appropriate city and state agencies so that when passengers are present in the vehicles, the passengers will pay the toll rather than the driver. Again, these mitigations would be for New York City taxi and FHV drivers if a tolling scenario is implemented with tolls of more than once per day for their vehicles. CBTA will work with MTA New York City Transit to institute an employment resource coordination program to connect drivers experiencing job insecurity with a direct pathway to licensing, training, and job placement with MTA or its affiliated vendors at no cost to the drivers. For those who may not want a commercial driver's license, CBTA will coordinate with MTA New York City Transit to submit a request to the Federal Transit Administration for a pilot program that will help increase eligibility of taxi and FHV drivers to use their vehicles to provide paratransit trips. And MTA's New York City Transit will implement this program if approved. With respect to construction effects, no adverse effects were found. Construction would consist of replacement of existing poles or installation of new poles and mast arms, excavation and construction of foundations, placement of new support poles or structures, attachment of tolling system equipment, and restoration of the roadway, sidewalk, or ground surface. The construction would occur on streets and sidewalks and take approximately 1 to 2 weeks per location. During this time, there would be temporary disruptions to traffic and pedestrian patterns, and temporary noise disruptions at nearby land uses such as residences and businesses. The project sponsors would require the contractor to develop and comply with plans and procedures to minimize construction effects. With respect to visual resources, there were also no adverse effects. Infrastructure is similar in form to streetlight poles, sign poles, or similar structures already in use throughout New York City. Signage is similar in size and character to signs already present, and the color would match existing light pole colors. On the bottom right, there's a rendering of tolling system equipment that would be placed on existing infrastructure. Again, as noted earlier, the tolling equipment is clustered into those single enclosures to reduce visual impact. And cameras would use infrared illumination at night, so there would be no visible light needed. The project would have a neutral effect on viewer groups and no adverse effect on visual resources. With respect to Section 4F, a de minimis impact is one that, after taking into account any measures to minimize harm, results in either a Section 106 finding of no adverse effect or no historic properties affected on a historic property, or a determination that the project would not adversely affect the activities, features, or attributes qualifying a park, recreation area, or refuge for protection under Section 4F. Central Park and the High Line have the potential for a de minimis use. Federal Highway Administration is soliciting input from the public on the effects of installing equipment and signs within and on these properties. Signage and 4 replacement poles with tolling technology would be installed in Central Park. Tolling technology equipment would be added to the underneath of the existing structure of the High Line. You can see some of the renderings at the bottom here. With respect to the findings, the Central Business District tolling alternative does not result in adverse effects pursuant to Section 106 of the National Historic Preservation Act, and it does not adversely affect the activities, features, or attributes that qualify the resource for protection under Section 4F. Federal Highway Administration has concurrence on a proposed finding from officials with jurisdiction over Central Park and the High Line, and will consider public input on its proposed finding received during this public review of the environmental assessments. There are 2 final additional enhancements I would like to mention, and again, they were in response to outreach during the early outreach period. First, the project sponsors are committed to ongoing data collection and reporting on the potential effects of the project. Data will be collected in advance and after implementation, and a formal report will be issued 1 year after implementation and then every 2 years thereafter. The reporting website will make data, analysis, and visualizations available in open data format to the greatest extent possible, with updates provided on at least a biannual basis as data becomes available and analysis is completed. Again, through our conversations and public outreach, and particularly with environmental justice communities, we are also committed to prioritizing equity in bus service improvements. New York City's buses serve a greater share of low-income minority households than other modes, including subways. MTA developed a new approach that combines considerations of equity and air quality to identify equity priority areas, which are then used to target improvements and investments to promote equity and access to opportunities in transit-dependent, historically marginalized, and underserved areas. Information on our early public outreach is here on the left. During that period, we held 10 virtual public outreach meetings, as well as 9 environmental justice outreach meetings. We had 3 meetings of the Environmental Justice Technical Advisory Group and 2 meetings of the Environmental Justice Stakeholder Working Group. During the 19 public outreach and EJ outreach meetings, we had over 1,000 participants registered and nearly 400 speakers. All of the sessions were left on our project website and people could access them through YouTube. To date, we've had over 14,000 views and we've received over 7,300 comments. Our current public outreach sessions will include 6 public hearings, starting on Thursday, August 25th and running through Wednesday, August 31st. We will also have another meeting of the Environmental Justice Stakeholder Working Group and another meeting of the Environmental Justice Technical Advisory Group. With respect to schedule, this shows where we currently are. We did our early public outreach in 2021 and early 2022. We prepared the environmental assessment. We've notified agencies and organizations and individuals of the environmental assessment's availability. And we're now in the midst, in orange here, of public review and comment on the environmental assessment. After the formal comment period closes, there will be a determination whether the action, in this case the tolling, will result in significant effects. Ultimately, we're expecting that in early 2023, Federal Highway Administration will issue a decision document. If adverse effects are not significant or can be mitigated below significant levels, FHWA would issue a FONSI, a finding of no significant impact. If there are significant effects that cannot be mitigated, then an environmental impact statement, or EIS, would be required. As noted, our public comment period is open until September 9th of 2022. If you'd like to submit written comments, you may do so in the following ways: through our project website, by email, mail, phone, or fax, or to the Federal Highway Administration by email or mail. All of this information is also available on our website, and the information on the project website, email, mail, phone, and fax for MTA bridges and tunnels is also in the environmental assessment. In addition, formal oral comments can be made at the public hearings, as many of you are doing today. They will be recorded by the stenographer. Thank you again for attending this public hearing to learn more about the environmental assessment for the Central Business District Tolling Program. And now, we look forward to hearing from you.